All right, everybody can see?
I can see it.
Yes.
All right, thank you guys. All right, so this is on average and instantaneous rates of change. Our learning goals are to learn the difference between the average and instantaneous rates of change and how it relates to calculus. We're learning to apply average and instantaneous rates of change to word problems. Hopefully a lot of you remember that when you were in grade 9, slope and rate of change were one and the same. And you probably got that a lot, okay? What's the slope, what's the rate of change? They were both m and same thing, okay? So we're still talking about slope. The average rate of change of a function between a point where x is a to where it's x is b can be found using, basically this is just the slope formula. So f at b minus f at a is like your y2 minus your y1. Over your b minus a is your x2 minus x1 there. And so average rate of change you can think of as being the slope of a secant, or the slope that joins 2 points on a curve. Okay, in this case, the diagram that I've got shown for you there, you're joining points P and Q, but P and Q could be anywhere. You could have P here and Q over here and draw in a secant, and that would still represent an average rate of change. It's just that this would be your A and this would be your B. Okay, so average rate of change, just kind of regular slope. And it's the rate of change over between A and B. Instantaneous rate of change. Now we're talking the slope of a tangent to the curve at a specific point. Okay, so because it's the slope of the tangent, now our formula for instantaneous rate of change is the limit as h approaches 0 of f at a plus h minus f at a over h, which should look familiar to you. That was our slope of the tangent formula to find the slope of the tangent at a specific point that we learned yesterday. So we'll look at a question here and figure out how we use those ideas to solve it. It's word problems. So the first word problem is a pebble is dropped from a cliff 80 meters high. After t seconds, the pebble is s meters above the ground, where s at t is equal to 80 plus 30t minus 5t squared. And then it also says that t has to be between 0 and 8. So the time is between 0 and 8 seconds. And the first thing it says is to calculate the average velocity of the pebble between 1 second and 3 seconds. Okay, I really like doing diagrams for questions. So I know time's going to be on this axis, and S, which is position, is going to be on this axis. And it says a pebble is dropped from a cliff 80 meters high, and we also see this 80 here is our initial value. We also know it's quadratic because the highest exponent on t is a 2. So if this is 80 meters up here, and I'm dropping a pebble, I'm kind of thinking it's going in this kind of parabolic shape downwards. Okay, I also see that the negative in front of the t squared terms tells me that it's a upside down parabola. Okay, this isn't the vertex 80, but it is where it hits the position axis. All right, I just like to do that because it might help us make sense of our solution. So calculate the average velocity of the pebble between 1 second and 3 seconds. So for average velocity, I'm going to use v for velocity and then put a little subscript average. So that's kind of meaning average rate of change, but really average velocity, because this is specifically a velocity question, and velocity is a type of a rate. Usually units for velocity would be meters per second or kilometers per hour, if you haven't taken physics before. So our V average is going to be, according to our formula here, F at B minus F at A over B minus A. So in our case, I'm not going to use F, I'm going to use S. So this is my A, 1 second, and this is my B, 3 seconds. So S at 3 minus S at 1 over 3 minus 1. So then I'm going to actually find S at 3. And I can just do that using my calculator. So I've got 80 plus 30 times 3 minus, I know that's going to be 45, 125. And I know it's meters. I'm not going to include those until the units until the end, but I'm told that position is measured in meters in the question. And then S at 1 so that's going to be 80 plus 30 minus 5, 105. So if I'm looking at my little diagram here, that means at 1 second, I'm at 105, so it goes up a little bit here. More like that. So 1 second, I'm at 105. And at 3 seconds, I'm at 125. I'll redraw this again. Sorry, guys. Here's my 80. There. At 3 seconds, I'm at 125. So I would be expecting if I was going to join those, I'd have a positive slope. So S at 3 is 125 minus position at 1 is 105 over 3 minus 1, which is 2. So that's going to be 20 over 2. And then your rates always have to have units. So that's 10. The units for the top is position, so it's meters. The bottom is time, so it's seconds. So my units are meters per second. So the average velocity of the pebble between 1 second and 3 seconds is 10 meters per second. So therefore, average velocity is 10 meters per second. And it makes sense to get a positive answer from my diagram. Any questions about that one? Average. Okay, so part B is the same type of question. Calculate the average velocity of the pebble between 1 second and 1.5 seconds. So our formula is going to set up the same, except for this is my A again. This time B is going to be 1.5 seconds. So I want S at 1.5 minus S at 1 over 1.5 minus 1. And we have to find s at 1.5 using our defining equation up here. So s at 1.5 is going to be 80 plus 30 times 1.5 minus 5 times 1.5 squared. Which gives me 113.75 meters. And we already know s at 1 from up here is 105 meters. So then I can put these into my formula. So the average velocity is going to be 113.75 minus 105 over 0.5. Which is going to give me 8.75 divided by 0.5. Which is 17.5 meters per second. So therefore, the average velocity is 17.5 meters per second. What does that mean that when we take the average velocity between 1 second and 3 seconds, our average velocity is 10 meters per second? Then when we only take it between 1 second and 1.5 seconds, it's 17.5 meters per second. It's bigger.
Its initial velocity was faster.
Right, so it's slowing down, okay? It's slowing down, very good, good. All right, so there's two examples of how to find the average velocity. So for C, we're going to calculate the instantaneous velocity. As soon as you see instantaneous velocity, you're thinking tangent, limit, calculus. Okay, at 1 second. So instead of calling it V average, we're going to call it V instantaneous because this is a velocity question. And we're going to say it's the limit as h approaches 0. And because this is our 1 second is our time, that means A is going to be 1 of S at 1 plus H minus S at 1 over H. So that's going to be our formula for finding the instantaneous velocity. We already, again, know S at 1 because we've had to calculate it before. But now we're going to find S at 1 plus H, which we've also worked on doing. In the past few lessons. So remember, we use our defining equation. So going way back up to the top, this is what's going to help me get S at 1 plus H up here. So it's going to be 80 plus 30 times 1 plus H minus 5 times 1 plus H squared. And then I need to expand and simplify that so I can put it in my formula. So I can distribute that 30. And then here I'm going to square the binomial. I saw lots of you are able to square the binomial right in the brackets without writing it out twice. So that would give you, if you square this binomial, 1 times 1 is 1, plus 2h. So you multiply these two together and then multiply them by 2 to get the middle term. Square the first term to get the 1. multiply the first and last and multiply by 2 to get the middle, and then square the last one. Or you can just write it out twice, that's fine as well. Be sure that you're right. And then distributing the -5 into all of them. A few of you yesterday only distributed over the first one, over the first two, and forgot the third one. Again, it's a common mistake to make especially when you're going quickly. I've done it before many times. Great, so simplify it down. 80 plus 30 minus 5 is 105. No, 100 yeah, 105. Plus 30h minus 10h is plus 20h minus 5h squared. So there it is, simplified down. So now we can go back over to this side and plug it in. So S at 1 plus h is 105 plus 20h minus 5h squared minus S at 1, which is 105 over h. And then we can see that in the numerator, we've got this 105 and minus 105 that make a 0 pair. I might also see that I can factor h out of the numerator now that I don't have those 105s anymore. Divide out my problematic h in the denominator. And now, because my denominator is 1, I can let h approach 0. So as h approaches 0, gets smaller and smaller, almost to 0, then 5h also approaches 0. So B instantaneous is equal to 20. And then units, rates of change always have units, and in this case it's velocity, and it's meters per second. The instantaneous, so at 1 second, the instantaneous velocity is 20 meters per second. So therefore, the instantaneous velocity at t equals 1 second is 20 meters per second. So again, that is an indication that it's slowing down. So at 1 second, its instantaneous velocity is 20 meters per second, but between 1 and 1.5 seconds, the average velocity is 17.5. So it's on its upward trajectory before it reaches its maximum height and is slowing down. And when it reaches its maximum height, its velocity will be 0. And then it will start coming down. Any questions for that one?
So I'm wondering at like 3 seconds,
Yep.
we could find the instantaneous velocity for like just any of these, like 3 seconds.
Yep.
I guess on like a quadratic function like this, like it's not going to be just the average is like halfway in between the two of them, but it'll be a little more.
Right, because it's, right. Yep.
Okay.
I know that if I was asking you to find the maximum, like how the maximum height or whatever, you could use quadratic reasoning, but we're going to try to do all this stuff using calculus.
Mm-hmm.
Because it's good to compare back to having a. You'll see, there's one coming up where you'll see
Okay.
what I'm talking about. Any other questions for this one? All right. Okay, here we are. Here's the next part. When is the pebble at rest? When is the pebble at rest? So something's at rest when its velocity is
0.
0. Everybody good with that? And if we do our little rough sketch here, which I now know goes way up and then comes down, the velocity is going to be 0. Here is where I would have my tangent line being horizontal. So at the maximum is where my instantaneous velocity is going to be 0. All right, so we're going to do that. We're going to find out where, using calculus rather than using quadratics, we're going to find out where the pebble is at rest or the instantaneous velocity is 0. And how are we going to do that? We're going to do this. So the instantaneous, we know in general, is the limit as h approaches 0 of s at, now instead of using x for an unknown, I'm going to use t because it's time. We're trying to find the time when it's at rest. S at t plus h minus s at t over h. And then I'm going to go and find s at t plus h using that defining equation again. So s at t plus h is going to be 80 plus 30 times t plus h minus 5 times t plus h squared. And then I want to simplify that out. I'm going to write the t plus h out twice here to make sure everybody's got how to get this. I'm trying to make my t's look hooked so that you don't mistake them for plus signs. So t squared plus th plus th plus h squared. So then I've got to distribute the -5 to all three things in the brackets here. So that's a lot. That's s at t plus h. I'm going to look and see if I have any like terms, but I don't think that I do. And then remember, just plain s at t was given to us in the question, 80 plus 30t minus 5t squared. So now we have this. And we have this. And we also have this. I'm going to color out here. What's this, guys? Be instantaneous.
It'll be 0.
It would be 0. Excellent. Okay, so I got 0 equals the limit as h approaches 0 of this big thing s at t plus h. So 80 plus 30t plus 30h minus 5t squared. Sorry. minus 10th minus 5h squared. So that's all the orange one, minus in brackets 80 plus 30t minus 5t squared all over h. And there's no way I'm going to fit the next line down because of this, so I'm going to come way down here. So 0 equals the limit as h approaches 0 of 80 plus 30t plus 30h minus 5t squared minus 10th minus 5h squared. And then I have to multiply this minus 1 through here using the distributive property. So that's going to be minus 80 minus 30t plus 5t squared over h.
Ms. Northwood?
Yep.
I'm wondering, since all there's the stuff is like all this, the minus stuff in the brackets there.
Yep.
I guess for everything in the brackets that's being minus, there are also things on the left that are also in the equation.
Yep.
I guess like they would like that whole block could kind of cancel out with like.
It does. I just want to make sure everyone realizes that that's going to happen. Okay. So if you distribute that negative correctly, or you think about it, yes, you're subtracting off all the terms. It'll turn out that don't contain an h, and that's what allows you to be able to common factor out that h there. So what's left? Everything that's left should have an h in it. So that's left, and that's left. So now I can common factor out an h. So I can divide out the h that's not allowing me to let h approach 0 yet. And now that my denominator is just 1, I can let h approach 0. So if I let h approach 0, 30 will stay the same because it's not affected by h. And same with minus 10t, it's not affected by h. But as h approaches 0, minus 5h will also approach 0. So now you're left with this 0 equals 30 minus 10t, and it's time that we want to solve for. We want to know the time when the pebble's at rest. So we can solve that equation by adding 10t to both sides. Dividing both sides by 10. And after all that, we get t is equal to 3 seconds. So it turns out that its maximum occurred at 3 seconds, or it was at rest at 3 seconds. So that would be my therefore statement. Therefore, the pebble is at rest. At t equals 3 seconds. So meaning if you go back up to that diagram I drew, on the time axis, it would be 3 seconds when the pebble had reached its maximum. It stops for an instant. Its instantaneous velocity is 0 there, and then it starts to fall back down to the ground. It's finished rising and starts falling.
Ms. Northwood?
Yep.
I guess, is it, I'm just wondering, like, I'm just noticing here, like, is it a property of quadratic functions where, like I'm just, like, if you go back to where we calculated the average between
Yep.
1 second and 3 seconds,
Yes.
got 10 meters per second,
Yes.
which is the average between 20 meters per second and 0 meters per second. Like, between the two, like the one at 1 second and the one at 3 seconds that we got.
Sorry. Say it again.
Like, at 3 seconds, the velocity is 0 meters per second.
Yes.
At 1 second.
Oh, I see. Yeah.
So is that like a property of quadratic functions where you just take the final instantaneous velocity and the initial one, and that could give you the average? Like, if you just average those two numbers? Or?
I'm not sure.
Yeah.
That's a good question.
Yeah.
I don't know if it's a I don't know if it's a property.
Yeah. It's just interesting.
It is interesting. Any other questions? Yep. Okay. All right, next question. Position of a particle is given by the equation S at t is the square root of 4t minus 3, where t is measured in seconds and s is measured in meters. Find the average velocity from t equals 1.75 seconds to t equals 3 seconds. Okay, so again, important word in this one would be that you're asked for the average velocity. So your setup is going to be the average is equal to s at 3 minus s at 1.75 over 3 minus 1.75. And then you're going to go and find s at 3 using your defining equation. And it turns out to be 3, which is nice. And that's meters, measured in meters. S at 1.75. That turns out to be 4, which also has a nice square root, so makes it our calculation easy. So then we can substitute those in. So s at 3 is 3. S at 1.75 is 2. 3 minus 1.75 is 1.25. Zero 0.8, and then it's meters per second. Therefore, the average velocity is 0.8 meters per second.
Do you want the full sentence every time, or is it okay if we just write therefore VAV equals?
So what I would have said during a regular class would be during homework and practice, then just do that. But on a test, write the full sentence out for your therefore statement.
So does that go for like assignments or?
Yeah, because that's my only way of testing you guys, really, because I'm not going to do big tests when we're doing remote.
Stop trying to cut out work, Hannah. Come on.
I get it. Like, I totally get it. When I'm doing my homework, I would always just do therefore VAV equals. All I would do actually is add a therefore right there, Hannah. Totally with you on that, but just for the future, for what you might have to do. You don't want to lose a communication mark on a university test, although a lot of first-year university tests are going to be mainly multiple choice. But they will usually pick out a question to look at your communication. All right, instantaneous velocity at t equals 3 seconds. So v instantaneous is going to be the limit as h approaches 0. I only saw, I think, one assignment yesterday where people left the limit off, or a person left the limit off and had to erase and squeeze it in everywhere. But that's a really common thing too. So don't feel bad about that. I've had to do it myself in the past. But try to always match up instantaneous velocity with the limit. Tangent, okay. All right, so do we know S at 3? We already do. So we already know S at 3 was 3 from above. Now we have to find S at 3 plus h. So that's going to be the square root of 4 times 3 plus h minus 3. Distribute, so that's 12 plus 4h minus 3. And again, why can I not take the square root of that? Why can't I make that 3 plus 2 some h something? Why can't I do that? Because of this plus here, okay? So this is a number here. I can't just take the square root of each part of it. I have to find the sum and that before I square root it. So make sure you don't be tempted to do that because you see 9 is a perfect square and 4 is a perfect square. Don't. Okay, so I'm going to replace s at 3 plus h with the root of 9 plus 4h. And s at 3 with 3. And I can't let h approach 0 because then the denominator approaches 0. So I have to use multiplying by the conjugate, which we seem to all be getting good at. So our conjugate radical is going to be root of 9 plus 4h plus 3. And when we multiply these two binomials, that's where it sets up really nice that the middle terms add up to 0, and I'm just left with the square of the first two and the square of the last two. Still going to write them all out because we're just learning here. But if you've got it down, then you can go to the step that comes after this one. So when I multiply these two together, I get 9 plus 4h. When I multiply these two together, I get plus 3 root 9 plus 4h. When I multiply these two together, I get minus 3 root 9 plus 4h. And when I multiply the lasts together, I get minus 9. When I multiply the denominators, I'm just going to leave it as h root of 9 plus 4h plus 3. These add up to 0. So do those. So I'm just left with 4h over h root of 9 plus 4h. Plus 3. And now those h's divide out. So now it's safe to let h approach 0 because even though there's an h in the denominator, the whole denominator is not approaching 0. Okay? So my V instantaneous is going to be 4, is unaffected by letting h approach 0, root of 9, because the 4h does approach 0, plus 3. Which is 4 over 3 plus 3. You don't have to show all those steps to get to the answer. 4 over 6, which is 2/3 meters per second. And then therefore, the instantaneous velocity is 2/3 meters per second. If you get a nice fraction like 2/3, I'd for sure leave it in exact form rather than saying approximately 0.667 or something. I'd rather leave it as 2/3. Prevents you from rounding. You give a very exact answer. Any questions on that one? Okay. All right, a different question now where it's not a velocity question. A doctor administers 10 milligrams of a radioactive tracer into a patient before a heart scan. The amount of dye in the body T hours after being injected is given by the function A at T. So amount at time T is equal to negative 0.2 T squared plus 10. How much dye is in the body after 2 hours? Notice how in this question, it doesn't ask you about any rate. It doesn't ask you about an average rate or an instantaneous rate. It just says how much dye is in the body. Anyone think they know what this question's asking me for? How I would find the answer?
Just evaluate A at 2.
Yeah. Okay, so all this question really is asking me for is A at 2. Great. So what's the amount in the body when T is 2 hours? Very good. And that's just a calculation. So that's 9.2. A at 2 is 9.2. And then look for units. Milligrams. Going by the question there. So how much dye is in the body? Therefore, 9.2 milligrams of dye is in the body after 2 hours. All right, now we get into what is the average rate of change over the first 2 hours? And this is a good question too, because over the first 2 hours implies that my 2 times, because this is an average rate, are 2. So B is 2. What's A? If it says over the first 2 hours, what am I starting at?
0.
Good. Okay, so I'm starting at 0 hours and going to 2 hours. So I want to write my formula out. Now, average rate, there's a lot of ways to write it. Some people just write AVG rate equals, okay? Some people still use V for rate. And then, so they still call it V average, which I'm not really opposed to, although V does stand for velocity. I usually just write average rate, okay, like that.
Could you do M average?
Yes, M average, rate. I've seen rate average like that, okay. All fine. So my average rate is going to be not S this time, so be careful. It's going to be A at 2 minus A at 0 over 2 minus 0. And I already know A at 2 because I found it out in part A. A at 0, I can see it's going to be 10, but I'll just show it. And it's going to be negative. What would the significance be that we're getting a negative average rate of change over the first 2 hours?
The amount is decreasing.
Yeah, the amount in your body. So when they first inject it, you've got 10 milligrams in your body, but your body's getting rid of it. So it's the amount in your body decreases over time. So therefore, the average rate of change over the first 2 hours is negative 0.4 milligrams per hour. Awesome. Okay, and this is our last question. What is the instantaneous rate of change of the dye in the body at t equals 2 hours? So we could do instantaneous, so INST rate equals, or you can do M instantaneous or rate instantaneous, however you want to write it. And it's going to be the limit as h approaches 0 of A at 2 plus h minus A at 2 over h. So I know A at 2, I have to find A at 2 plus h. And that is going to be negative 0.2 times 2 plus h squared plus 10. If I square that binomial, I'm going to get 4 plus 4h plus h squared. Distribute. So that's going to be negative 0.8 minus 0.8h minus 0.2h squared plus 10. And these are like, so that's 9.2 minus 0.8h minus 0.2h squared. So this is this. So I can substitute in. So A at 2 plus h is going to be 9.2 minus 0.8h minus 0.2h squared. And then minus A at 2 is 10, sorry, 9.2. You found that in the first question, all over h. If I simplify the numerator, I have 9.2 and minus 9.2, which is always a big relief. Everything left in the top has an h in it. So I can common factor the h out. Divide the h's out. And now that my denominator is 1, I can let h approach 0. So So as I let h approach 0, my rate is going to be negative 0.8 milligrams per hour. Always make sure you have units whenever you're giving me an answer that's a rate of change. Okay, the units are worth a mark for sure. Okay. And then we need a therefore statement because it's a word problem. So therefore, the instantaneous rate of change at t equals 2 hours is negative 0.8 milligrams per hour. Any questions about that last one? Good. All right, that is this morning's lesson. So there's practice questions for you to do. Attached here, so that these questions, there's answers at the bottom, and then I'll also post full solutions in a minute. When you're done those, give yourself a little break and then watch the next video that I will post, and then do those practice questions. I know the practice questions are a little bit blurry, so if there's something you have to ask, just message me or look at the solutions. And then have your assignment hopefully in by 4 o'clock. If you can't, just give me a message saying, I'm working, it'll be in later, and I will check later. All right, I'm going to stop recording and then I'll see if there's any other questions.